Okay, so today what we're going to be doing is we're going to be simplifying roots. And what I mean by that is I don't just necessarily mean square roots, which is what you're most familiar with. We will be simplifying square roots. And remember, with a square root like that, what you have is you have sort of an invisible 2 outside. You know, it won't be there, but you have to remember that that's to the second. So it's like a second root. We will also be dealing with third roots, what we also call cube roots sometimes. You will see the 3 there. That's the way to know the difference between a second root, which is a square root, or a third root, or even, in this case, what we're going to do is a fourth root. The rules that we're going to learn today, you can do for 5th root, 6th root, 7th root. It doesn't matter. It applies to all of them. But mainly we're going to start with 2nd, 3rd, and 4th, because everything beyond that is just another iteration of what we're doing. Okay, so for the first example, we're going to look at this problem right here. We're going to look at the square root, simplifying the square root of 72. Why do we need to simplify it? Well, I don't know what the square root of 72 is. I don't even really know what it's close to. However, I do know it's in between 8, which is 64, square root of 64, and 81, which is square root, or square root of 81, which is 9. So it's in between 8 and 9. I just like to know like a smaller number that I can use as a reference. So what we're going to do is we're going to follow basically 3 simple steps. The first step is we're going to take that 72 and we're going to make a factor tree. Now, if you don't remember what that means, the word factor right there, that basically means 2 numbers that multiply together to equal a larger number. So we're looking for 2 numbers that multiply together to equal 72. Probably some numbers jumped into your head. I went ahead and used 2 and 36. The reason I do that is because of this number right here. What we want is we would like, if we can, to have a prime number on the left side. The reason is I don't have to factor 2 anymore. Okay, 2 is already factored. So if I had something like, for example, 6, I'd have to divide that into 2 times 3. So instead of getting my sort of tree branching both directions, I want my tree only to branch on the right side. So now I'm going to break 36 up. Again, I would like to use prime numbers. So I went ahead and used 2 times 18. Other numbers would have worked as well. Okay, now I'm going to break up 18, which is going to be 2 times 9. Notice I'm only having to break up the right side because I'm picking prime numbers for the left side. And again, now I'm breaking 9 up, which can only be broken up one way, 3 times 3. We don't do 1 times 9 because we could do that forever. Okay, at this point now, all I'm going to do is I'm going to pay attention to the numbers that are on the left side, so to speak. Basically my prime numbers. A lot of people get confused and think the 36, the 18, and the 9 are important. They're not, because I've already used them. When I broke this up into 2 times 36, I used the 72 above. When I broke that 36 into 2 times 18, the 36 is gone. Then I broke 18 up, then I broke 9 up. So those are, in effect, gone. Okay? So all I'm going to pay attention to is my prime numbers on the left side and on the bottom. What the rule says is every time I have a prime number and I have 2 of that prime number, basically the square root will sort of cancel out. So what's going to happen is if I have 2 2's, that's the equivalent of 1 2 on the outside of the square root sign. So what I look at is I look, hey, I've got 2 2's right there. That is the same as 2 times 2, which is 4. Square root of 4 is 2. So because I have 2 of them, it's able to come outside. Now I'm going to look for another pair. Sometimes I have more than one, sometimes I don't. If you notice, I have 2 3's down at the bottom. Okay, because of that, I can have 1 3 that comes on the outside. That is not 23. I need to have some notation there. Because we're talking about factors and factors are multiplied together, those 2 numbers are going to be multiplied together as well. Now, something's left over. If you notice down at the bottom, we still have that 2 right there. That 2 needs to be used in some way. What happens is it doesn't have a pair, so it has to remain inside the square root sign. I don't know what the square root of 2 is. I can't break that up into a number I know and bring it outside. So what happens is that 2 then ends up staying inside the symbol. At that point, all that's left to do is go ahead and simplify my answer, which ends up being 2 times 3, which is 6 square root of 2. The same thing would be true if I had 2 things inside the square root sign. I would need to multiply them together to simplify. Now, some of you are thinking, okay, great, but I didn't think to do 2 times 36. So am I going to get this problem wrong? No, you're not. And in fact, you can do it a lot of different ways, and I'm going to show you why. So let's say most of us probably thought that the answer would be 8 times 9. Okay, and I think that's just because we were memorized all these multiples of 9 when we were kids. And that's totally fine to use. You're going to see the only difference is you're going to have to branch it out in 2 directions. So now I have to take my 8 and I have to break that up into 2 times 4. And then my 4 into 2 times 2. Still fine, nothing's gone wrong. You may be thinking, oh, I'm getting different answers. You're not in the end. Okay, so now I'm going to break down my 9 into 3 times 3. Again, the question here is, am I going to get the same thing? A rule in math says, fundamental theorem of arithmetic says, you have to factor a number in one unique way, as long as you factor it down to prime factors. So now I'm at prime factors, 2's and 3's. Again, I'm ignoring the 8, ignoring the 9, ignoring the 4 because I have broken those up into prime numbers. Now I'm going to look for my pairs. I notice I have a pair of 2's, which equates to a 2 on the outside of my square root sign. Okay, I also notice that I have a pair of 3's. Okay, so I'm going to go ahead and do that, and I'm going to put my 3 on the outside. Okay, what stays inside my square root sign is whatever numbers I have not used yet. So as you probably notice, I still have this 2 left over right there, which then goes inside my symbol. If I go ahead and simplify that, I get 6 square root of 2, the same answer we got before. So the good news is it's very difficult to do this wrong as long as you don't mess up your basic multiplication tables, and as long as you don't forget that you have to continue to factor until you get to prime numbers. So let's look at one more example together. We're going to go ahead and we're going to simplify square root of 150. Again, you can probably think of several ways to break this number apart. I'm going to try to always do a prime number on the left side. So for me, I did 2 times 75. You might have thought of 15 times 10. You might have thought of other things like 3 times 50. Probably a bunch you could think of that I can't. Now I'm going to continue to break this up. I'm going to break up 75. Again, if this is difficult for you, you can even go back. You could say, hey, I don't know how to break up 75. So I'm going to go back and I'm going to start over and do 15 times 10. The idea is to continue to factor until there's nowhere else to go. And that's what we want. We want this to be simple. So use numbers you're comfortable with. In this case, if we think about money, obviously 75 is 3/4, 3 times 25. And 25 is only broken up into 5 times 5. So now all I have to do is follow those same steps. Collect my pairs. In this case, all I have is a pair of 5s. And then whatever's left on the outside that are prime numbers has to stay inside the square root sign. So as you can see up above, I still have left over a 2 and I have left over a 3. Okay, those are prime numbers. I do not care about 75 or 25 because I have broken those up into smaller pieces. Okay, now that 2 and the 3 stay inside, and all it's left to do is simplify. 5 square root of 2 times 3, which is 6. What I want you guys to do for a second is I want you to pause the video, and I want you to go ahead and try to do this one on your own. It's a small number, so it'd be simple. Remember, you can break it up into any way that makes sense to you, but try to get in the habit of putting a prime number on the left side. It just makes the process easier because you don't have to branch as many directions. So go ahead and hit pause, and when you're done, go ahead and play the video, and you'll check if your answer is correct. Okay, so hopefully you guys have done the whole problem now, so let's go ahead and take it out. I went ahead and did 2 times 12. Remember, if your numbers were different, all you're going to be worried about is my final simplified answer the same? Now I'm going to break up 12 into 2 times 6. 3 times 4 would have worked fine. And 6 can be broken up into 2 times 3. Now I identify my perfect squares. I identify my pairs. So I have a 2, which is going to go on the outside. And on the inside, I still have a 2 and a 3 left over, which again multiply out to equal 6. So hopefully the answer was correct. If not, you might want to go ahead and go back to the previous examples, rewind the video, and just sort of watch through the process again. You'll have plenty of opportunities to practice this tomorrow in class. Okay, now what we're going to do is we're going to go ahead and we're going to look at an example with a 3 on the outside. It is incredibly important to notice that 3 because the process, while the same process, changes in that instead of taking 2 to exit the square root sign, so to speak, now we need 3 to exit the cube root sign. So we're going to go ahead and follow the same process. We're going to make our factor tree, continue to follow that process. Okay, now what I notice is, hey, I have 3 2's. Continue to break this down. And again, now I'm down here. What I'm looking for this time is instead of a pair to exit, I need 3. So I obviously already had one trio of 2's. Now I have a second down here. Each one of those sets of 3 equates to 1 2 on the outside. So now I'm going to have a 2 on the outside, another 2 on the outside, and then what's left over, which is this 1 down here, needs to stay inside my symbol. One thing I want you to pay very close attention to is the fact that I wrote the 3 right there. And then I erased it. I wrote the 3 right there because if you forget that, unfortunately, the answer is incorrect. The third root of 2 is different than the second root of 2. You have to make sure you pay attention to detail. So after I get my 2 inside there, I simplify 2 times 2, and my final answer is 4 times the third root of 2, or 4 third roots of 2. You kind of add them together and stuff later, and we'll look at that later on. Okay, the last example we're going to take a look at is, what if there's a 4 on the outside? The reason, again, I said we don't go beyond that, because the process is the same. When there was a 3 on the outside, we needed 3 to exit the root symbol. Now that we have a 4, we just need 4 to exit the symbol. So we're going to go ahead and break these up as our normal process. At this point, you'll notice, hey, I have 4 2s there. Okay, that means it's going to come outside. Most of the time, people get mixed up. They sometimes take 2. They sometimes take 3. You need to pay attention to this symbol right here. It's very important when we do this because that dictates how we solve the problem. Continuing, I have to factor the 4 because it is not yet prime. And I am left with a 2 that comes on the outside of my symbol. And I am left with the 2 leftover 2s that have to stay on the inside. Again, 2 times 2 would equal 4. Okay, and this process is the same for all of them. I am going to give you a few examples to practice after this. And what I would like you guys to do is just make sure that this is something you're comfortable with. Tomorrow when I see you in class, we'll be doing more practice. Okay, so now we're going to have a moment to try some more problems on your own. Go ahead and write this problem down, pause the program, and as soon as you get your final answer and you're confident with it, go ahead and hit play. Okay, so hopefully you did the problem and followed the directions. I'm going to go ahead and show you the way I solved the problem. Again, if your answer is the same at the end, you're good, even if you use different numbers. Okay, so as you can see, we end up with 3 3s. So because it's a third root, one of those can come outside the root symbol, and what stays inside is going to be our 2. So we end up with 3 third root of 2. Okay, again, here's a second example for you. Go ahead and write down the problem, pause the video, and when you are finished, go ahead and hit play. Okay, hopefully you finished the problem. Okay, you'll notice it's a 4th root, therefore we need 4 to make it outside the symbol. So we have 4 2s, which equates to 1 2 on the outside. And on the inside, we still have our 2 and our 5 left over, which is going to be 2 times 5 is 10. This problem could have been started as 16 times 10, 4 times 40, a lot of different possibilities. Go ahead and pause the program and try this one again. Notice that it is not a third root or a 4th root, but back to a square root. Make sure you understand what that means when you solve this problem. Go ahead and pause the video and unpause it when you're finished. So go ahead and break the problem down. I did 5 times 100, and that determines everything else after it, obviously. You probably thought, hey, I would have done it a little bit different. That's totally fine. Here, when I get to this point, you'll notice I have 2 5s and 2 2s. So those both go on the outside. 1 5 goes outside and 1 2 goes outside. What is left over is the 5 you see there. So that ends up going inside the root symbol. And cleaning it up, we get 10. 2 times 5 is 10, square root of 5. Now on the left side, I put a square root of 500 symbol. And I did that because some of you might think of a shortcut to do this problem. When we learned it by using prime numbers only. However, if you look back at my very first step when I had 5 times 100, you might think to yourself, well, isn't 100 10 times 10? The idea is not that we can only take out the idea is that we can not only take out prime numbers, but we could take out any number that is multiplied by itself. So if you take that 100 and you break it down to 10 times 10, even though they're not prime numbers, because we have 2 of them and we are totally done factoring, those can then be taken directly out. And that will get us, as you can see, a 10 on the outside and a 5 to stay on the inside. So definitely look for those shortcuts, but if in doubt, just go to prime numbers. It will always work as long as you go to prime numbers. If you could find a way to do it a little bit simpler, that's good. So this is going to sum up our video for today. What I want you guys to do is take the survey at the end, answer any questions, and please put your questions you may have. Tomorrow we'll talk about this in class as well as during the practice time.